In this presentation, we will derive the exact values for special angles 30 degrees, 45 degrees, and 60 degrees. The special angles appear often in mathematics and in science, so your being able to derive their exact values will prove useful to you in trigonometry and calculus. In class, we will use these values to create a reference tool called the unit circle. We will begin by finding the exact values for the 30 degree and 60 degree special angles. To start our derivation, draw an equilateral triangle with side length 1. Since it's equilateral, all the angles are 60 degrees. Since we have an equilateral triangle with 60 degree angles, how can we create a 30 degree angle from this triangle? You may recall from geometry that we can bisect an angle using a perpendicular bisector, and that will create a right triangle that bisects the angle and bisects the base. This will provide us a 30 degree angle, and the base will now be 1/2. We will use this right triangle to obtain the trigonometric values for the 30 and 60 degree angles. Before we can begin, we need to get length h, which is the height. Since this is a right triangle, we can use the Pythagorean theorem, and we know the hypotenuse squared equals the sum of the squares of the opposite two sides. So in this case, 1 squared equals h squared plus 1/2 squared. When we're finding exact values, we do not use decimals. Please do not use decimal values. H squared equals 1 minus 1/4, so h equals the square root of 3 over 2. Let's write that in for h. Since we know this right triangle and its 3 sides, we can find the ratios for the sine, the cosine, the tangent of 30 and 60 degrees. The sine of 60 equals the opposite over the hypotenuse, so that's square root of 3 over 2. The cosine of 60 equals the adjacent over the hypotenuse, which is 1/2 over 1, which equals 1/2. The sine of 30 degrees equals 1/2 over the hypotenuse. The cosine of 30 degrees equals the square root of 3 over 2 divided by the hypotenuse, which is square root of 3 over 2. And the tangent of 60 is the opposite over the adjacent, square root of 3 over 2 divided by 1/2, which equals square root of 3. And finally, the tangent of 30 degrees equals the opposite over the adjacent, which is 1/2, divided by square root of 3 over 2. And after we rationalize the denominator, we obtain square root of 3 over 3. To summarize, here are our 6 values, and you'll find that if you commit these to memory, it'll be very helpful. However, if you don't have them memorized, you can always quickly work through the derivation. Let's now turn our attention to the sine, cosine, and tangent of 45 degrees. We'll begin by drawing an isosceles triangle with the side lengths are 1. Since it's isosceles and the side lengths are 1, these angles are 45 degrees. We need to get the length of the hypotenuse. The hypotenuse squared equals 1 squared plus 1 squared, so h will become the square root of 2. The sine of 45 degrees equals the opposite side divided by the hypotenuse, so we get the square root of 2 over 2. The cosine of 45 degrees is the same value, and the tangent of 45 degrees, which is the opposite over the adjacent, equals 1. In summary, the sine and cosine of 45 degrees are equal, which is the square root of 2 over 2, and the tangent of 45 degrees equals 1. This concludes the presentation.